Hi guys, welcome to HSC Chemistry in the acidic environment video series. I'm just going to walk you through some of the, I guess, nuts and bolts of titration. More today just to give you a general overview because we're going to do a lot of examples of these in class, but hopefully this will give you a bit of an idea about the important things associated with titrations, both procedurally and for calculations. So one of the things that you may be asked to do is to select an indicator, an appropriate indicator for each of the titrations that you carry out. Now the important thing about the indicator is that it has to demonstrate a distinct color change. We have to have a really clear difference in color once that equivalent point is reached. So one of the most common ones that we use is phenolphthalein. And in fact, we're going to select phenolphthalein for any reaction involving a strong base because it's just easier to do the titration against the sodium hydroxide and have that pinkish color just kicking in from the colorless solution. So it's much easier to use that one. The only time we wouldn't be doing that is if we have a weak base. So if we have a weak base, then we're going to shift our indicator to methyl orange. So that's the only variation to that. Because the equivalence points do differ slightly between titrations based on whether we have strong or weak acids against strong or weak bases, it's important that we choose an indicator that's appropriate for that titration. Of course, you will know that the key to it is what the pH of the salts that produced is at the equivalence point. And we've talked a little bit about the acidity, basicity, or neutrality of different types of salts. Of course, because this is a chemical technique, like any scientific technique, you want to make sure there is repetition. And the key to excellent volumetric analysis is technique. And it's also about making sure that you can get things within a very narrow range. So we want to make sure that we repeat the process several times, ensuring that the range is no greater than 0.2 of a mil, possibly less than or equal to will be acceptable, but we want to try and make sure that range is as small as possible. Better, of course, if it's less than 0.2. So you know that you're consistent in your techniques. Now, some of this is going to be a little bit limited by the limit of reading of your measuring devices, such as the electronic balancers, how accurate they are. But this is one of these techniques where we try and be as accurate as we possibly can. I suggest you use a bucket run, your first one, just to get a sense. When we're doing our first titration, we don't know whether it's going to go at 4 mils or at 40 mils, and you don't want to be going drop by drop for something that's not going to change until, 20, 30, 40 mils. So a bucket run gives us a good ballpark. We discard that. It's not going to be part of our calculation point. But what it will do is by overshooting the mark, it'll give us a good ballpark for where we want, where we need to take care with our subsequent runs. So the point then will be that your next 3 titrations will be your careful titrations that'll be as close to each other as possible. If one of them does fall outside of this range, then of course you're going to have to discard that one and repeat the experiment again. This helps with reliability and accuracy when you're doing your calculations later on. When we're going through our calculation steps, there's a couple of things that are important. We have to have a primary standard. Often we've used an organic acid as our primary standard, but sodium carbonate does work as a base for a primary standard. We must weigh it first so that mass can be used to calculate the number of moles. So here we're going from mass to number of moles. Now, of course, we can go from concentration and volume to moles as well. But for a lot of these primary standards, if we start with a certain mass, we can weigh on an electronic balance. That's a better way of doing it. We need to determine the mole ratio. This is very important for the number of moles of acid to base required for neutralization. So you'll need to know whether it's a mono, di, or triprotic acid, and then how many moles of your base are going to be required in order for neutralization. We carry out our titration and divide the number of moles by the average titer to get our final concentration using the formula C equals N on V. And remember that average titer is going to be based on the elimination of any outliers. So this allows us to standardize the concentration of our base if we're starting with an organic acid, and then we can use that standardized or known concentration to then titrate against an unknown, such as the amount of acid there is in vinegar, for example. So here's a little flow for you to get a bit of a sense of how you might go through for an unknown acid. I use this little series of arrows to try and get a sense of which directions we're going in and what steps are important. And when you start, you'll already know the concentration of your base because you've carried out a previous titration in order to find that value. The number of moles, volume, is the average titer volume. So this is going to be what's going to come in after you have carried out your titrations. So then we have number of moles is equal to CV. Remember, we put our name on our CV. That'll give us the number of moles of the base. Then we're looking at the mole ratio in order to get to D. So this is going to be the same if it's 1-to-1 as in this example, but it could also be a 1-to-2, 1-to-3, whatever it may be. The volume, you're usually going to pipette a certain volume of your unknown acid. So if we're testing vinegar, for example, we might take 25 mils of that vinegar solution and then titrate against that. And so then if we've got a number of moles here of our acid and our volume from our pipette, then the concentration is number of moles over volume. This equation is very, very important, and it's one that I suggest you write at the beginning of your exam, on the top of your exam, because you're going to use it all the time. We'll do some more examples in class, so hopefully this will be nice and solid by the time you get to your exams. Thanks for watching.